Here we are in section 8-2, exercises 17 through 22. Notice we're trying to find the x-intercepts of each of these parabolas. And so we are right here with the x-intercepts, and it's like it always has been before. We're going to stick in 0 for y. When we put 0 in for y, we have a quadratic, which means in solving, we could factor it, or we could complete the square, or we could use the quadratic formula. We'll call the quad form right here. The x equals negative b plus or minus square root. So these are three things that happen. We did this back in chapter 5. We did that in section 8-1, and now in 8-2 we have this one. So we have different methods for this, but we're doing this same thing. We're sticking 0 in there and finding there's potentially two x-intercepts. I think on 19 and 20, they're already in completed square form, so we'll probably use completing the square there. On the rest, we'll use quadratic formula, and then if we happen to get fractions or nice numbers, we'll know we could have factored and we just missed it. So let's try it. So we're going to stick in 0 right up there for number 17. Stick in 0 for y. We get 0 equals x squared minus 4x plus 3. And x equals negative b plus or minus square root b squared minus 4ac all over 2a. And now let's simplify. We get 4 plus or minus the square root of 16 minus 4 times 3, 12. That's a 4. That's a perfect square. That means this would have come out. This is 4 plus or minus 2 all over 2, which is 4 plus 2 is 6, divided by 2 is 3, and 4 minus 2 is 2, divided by 2 is 1. Oh, good grief. Yes, that would have factored into x minus 3, x minus 1. We would have got the same answer. So that means 3 will give us 0, and 1 gives us 0. That is correct. So we have two x-intercepts, and notice they are rational. It would have factored. The b squared minus 4ac under the square root came out to be very nice, a perfect square, so it gave us rational, nice whole number, actually, natural number, x-intercepts. Good. Let's move on and do the next one. Number 18, put a 0 there. Equals x squared plus 6x minus 2. Now it's in the proper format. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Good. Okay, so negative 6 plus or minus square root of 36 plus 8. Right? Plus 8, that's a square root of 44 all over 2. Okay, these are irrational. It's positive. It's not imaginary, so they are real, but it's going to be irrational. Let's see if we can simplify that down. 44 is 4 times 11. Oh, yeah. So this becomes, if we had square root of 44, that's 4 times 11, or 2 times 2 times 11. Square root of 4 is a 2 square roots of 11. So we get negative 6 plus or minus 2 square roots of 11 all over 2. So we can divide the whole top by 2, and we get negative 3 plus or minus square root of 11. So that gives us two answers. Negative 3 plus the square root of 11 is an x-intercept. And you could plug that into your calculator and see that that's about, I don't know, positive 0.4 or something. And then negative 3 minus the square root of 11, 0. So these are our two answers. Good. All right, number 19. Ooh, this is in completed the square form. So when we stick 0 in for y, that's over here, we're going to have 0 equals x plus 2 squared minus 9. It's already in perfect, a completed square. So let's add 9 over. X plus 2 squared, square root both sides. Oh, doesn't that bring back happy memories? And so we get plus or minus 3 equals x plus 2. Subtract 2 from both sides, and we get negative 2 plus or minus 3 equals x. So that's going to equal negative 2 plus negative 2 minus 3 is a negative 5. And negative 2 plus 3 is a 1. Wow, that's fascinating. These guys right here, if we would have distributed x plus 2 squared all out and then subtracted 9, it would have factored. I wouldn't have guessed that. So we get negative 5 at a plus 1. So we write it out as negative 5, 0 is one x-intercept, and 1, 0. And we note that these two intercepts represent that we have a U-shaped graph, and so we actually hit the x-axis twice. Good. All right, next one. Number 20. We're going to stick in 0 for y, and we get negative 2 x plus 5 squared minus 4. This is already in completed square form, so let's just peel it off. Add 4 to both sides. Negative 2x plus 5 squared. Divide both sides by a negative 2. We get negative 2 equals x plus 5 squared. Square root, and plus or minus. Ooh, notice right here what has just happened. We can identify, as soon as we know we got a square root of a negative, these answers will be complex. They'll be imaginary. They'll have imaginary parts to them. So they're not going to be real x-intercepts. That's fascinating. Let's go ahead and keep going. We got plus or minus I square roots of 2 equals square root squared. That's x plus 5 right there. And subtract 5 over. So we get negative 5 plus or minus I square roots of 2 equals x. Those are the two answers. Oh, we're supposed to write these as x-intercepts. All right, negative 5 plus I square roots of 2 or minus I square roots of 2, 0, which is kind of a misnomer. That's not a real point anywhere on the number line. So this U shape would be pointing away from the x-axis and never actually get there. Kind of a fascinating dilemma we find ourselves in on that guy. All right, number 21. Put a 0 here, and we get negative 3x squared plus 6x minus 3. We're quadratic formula. We can do it. This is in the ax squared plus bx plus c form. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Good. Oh, a lot of simplifying on this one. Let me see. Negative 6 plus or minus the square root of 36 minus, let me see, 4 times 3 is 12 times 3 is 36. Wait, 36 minus 36? Is that a 0? Oh my goodness. Look at that. If that's plus or minus square root of 0, that's kind of nice, over negative 6. Whoa, that's simplified down. Equals, well, negative 6 plus 0 divided by negative 6 is 1. And negative 6 minus 0 is negative 6. Divided by negative 6 is 1. We get 1 twice. We call that a double root. And we just write it like this. 1, 0. So this only has one x-intercept, which is interesting. That must mean that where the U shape of the parabola, it actually comes and this is the corner point. That's how you get just exactly one of them. Here, this one has none. These three up here have 2 real ones, and this one has none. That one just has exactly 1. So we call it a double root because it's kind of like it goes down and touches and comes back up at the same place. Okay, number 22. Final one. Stick 0 in for y, and we get 2x squared minus 12x plus 14. And x equals negative b. So that's a positive 12 because b is negative itself. Plus or minus square root b squared minus 4ac all over 2a. There we go. That's nice. Okay, so 12 plus or minus square root of, ooh, I'm going to need my calculator for that guy. 144 minus 4 times 2 times 14. Oh, 32. That wasn't as bad as I thought it was going to be. 32 all over 4. Can we simplify this guy? We could plug that into a calculator and get a decimal, but nah, let's make it look exact like these other guys and make it look pretty. So notice that this is a positive number, but it's not a perfect square. That means we're going to get 2 real answers, but they will be irrational. So 32, let me see, square root of 32, that's 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So we get 5 2's in here. So square root of 32, let's take that back just a little bit and write that out. And then we get 2 times 2 times 2 times 2 times 2. So that 2 comes out, that 2 comes out. So we get a 4 out in front with square root of 2. Okay, so we get 12 plus or minus 4 square roots of 2 all over 4. Notice we can take a 4 out of here and out of here and out of here and divide those. You've got to be able to take it out of the top. So this is 3 plus or minus the square root of 2. Excellent. So we can write it as, those are x-intercepts. You can write it like this, or you can write it up here like this, like we did on number 18. Writing it either way, this is 2 different answers. And you could stick that in and get like, I don't know, that'd be like 1.6 and 4.4 or something like that as decimals. Excellent.